We filled our game with swarms of dangerous enemies. We need a better way to deal with them. Time for super weapons. Let me show you something.
I collected enough plutonium to upgrade our reactor. I can focus its energy into a powerful column of light and use it as a weapon.
Sounds like things can get very hot very fast.
Yes, our solar shields will give us a source of renewable energy, but be careful not to overheat the cannon. The security lock will disable the valve if we surpass the maximum safe temperature.
Noted. We will manage our energy and avoid overheating. Sounds easy enough.
The laser can burn through multiple enemies at the same time. It can destroy the entire enemy wave in seconds if timed correctly. Happy hunting.
In this JavaScript game development class, we add resource management with a rechargeable energy bar, and we will implement two more weapons, a long-range laser and a super laser. These new weapons will be fundamentally different from our basic attack because they will hit all enemies in a column in front of them, even the ones all the way in the back. It can be very effective, especially later in the game when we face larger and larger enemy waves. We will have the parent laser class that will define the main properties and methods of both laser weapons, and I will extend it into two subclasses, small laser and big laser. I do it because each laser will have different size and it will deal different damage. Those specific things will be defined separate on each subclass. Constructor will need access to the main game object to give us access to all important methods and properties we previously put on the game class from inside laser class. Render method will draw and update the laser weapon, so it will need context as an argument. We will extend the constructor on both subclasses. Let's just first do everything on a small laser subclass to keep it simple. So when we create an instance of small laser, we want to run all the code inside its parent class constructor. We know that the parent class can be also called a superclass. We call superclass constructor like this, and we know it expects a reference to the game object, so I pass it here, like this. It is expected here, and it gets converted into this.game property. Only after we run the code inside superclass constructor, we can use this dot here and define properties specific only to small laser subclass. We will do that in a minute. I also want to extend render. I don't want to override it this time. I want the code from inside render from line 5 to actually run. This code block contains logic shared for both small laser and big laser subclasses. And after that, I will add a little bit of code that is specific only to small laser subclass here. The syntax is a bit different. It's like this. So here I'm calling superclass constructor. Here I'm calling a method that sits on the superclass, on the parent class. I hope it makes sense. Constructor is a special type of method. That's why the syntax is different here in these two cases, even though both are just calling a method on the parent class. There is a reason why I'm putting render method on the subclass, but we will get to that later. Laser will need X and Y, width and height properties, so that JavaScript knows exactly where to draw it. Also, we will be checking collision detection between the laser beam and the enemies and bosses, and we know that all objects involved in collision detection need X, Y, width and height properties. X, Y, and height can stay on the parent class, but each laser type will have a different width, so I have to put it on the subclass here. We want the big super laser to be much wider than the small laser. The small one? Let's try 5 pixels. The player sprite sheet will animate with these weapons, so we will get width to match the spaceship sprite in a minute. This.x, the horizontal coordinate of the laser, will be moving with the player as the player moves left and right. Initially, I set it to 0. Vertical y coordinate on both lasers will always be 0 because I want the laser beam rectangle to start from the top of the screen. The height of the laser will always be the same as well. I want the laser beam to come from here to somewhere around here, I guess. So from coordinate 0, and height of the laser beam will be this.game.height minus, let's say, 50 pixels to cover this area. We know that all the code inside constructor is executed only once at the point when we create an instance of the class using the new keyword. Render method will be very different. The code inside render method will run over and over for every animation frame, and we have to keep that in mind when we decide where to put the logic. When the laser is active, I want its horizontal coordinate to keep updating to match the position of the player. Let's just start with this and see what we get. Now I will draw the laser beam as a simple rectangle. I will give it 2 colors, so I will wrap this code block in save and restore built-in canvas methods to make sure that these fill style colors affect only the laser beam and not the other shapes drawn on canvas. I set its fill style to gold. Built-in fill rectangle method will draw the laser. I just pass it x, y, width from here, and height. If any of this doesn't make sense, leave a comment and we can talk about it. I hope it's all clear. We have the basic version of small laser. Let's draw it so we can see it in game and we can tweak it and adjust it. I will create an instance of small laser class here. So it will be created at the point when we create an instance of the player class using the new keyword. I could have also put small laser on the main game class, but I think it makes more sense here since it will be so closely tied with multiple properties on the player. Here we are checking if key is pressed and we are swapping player frames. I'm going to create an else if block. I have to be very careful about brackets when doing this. Single wrong bracket can break the entire game code. If 1 is pressed, we do the basic attack. When 2 is pressed, we will trigger small laser. Player sprite sheet is already prepared for this from before, so I just need to set frame x to 2, like this. We are inside the draw method, which runs over and over for each animation frame. As long as key 2 is pressed, we will be displaying frame x2, and we will be calling render on small laser, drawing it and updating it. As soon as we release the key, frame x will be set to 0 and we stop rendering small laser. If we press number 1, we do the basic attack. When we press number 2, we draw small laser. It moves around with the player. I want to move it to the middle of the player, so I adjust the code on line 9. Position of the laser is position of the player plus half of the player's width. Now it's almost centered. To center it completely, I have to offset it by a half of the width of the laser. Now it's exactly in the middle. As you can see, when we shoot the small laser, the arms of the spaceship move inwards to help focus the thin laser beam in a small area, and the small muzzle jumps a bit backwards. I will set laser width to 50 pixels, just so we can better see it, and I will give it additional color. Because the middle of the laser is so hot, I want it to appear pure white. I copy this code block, I set it to white. It will be, let's say, 60% of the width of the laser beam, which leaves us with 40%. To center the white beam in the middle of the gold beam, we need to push it by 20% of the width from the left edge, pushing it exactly in the middle. Now the middle of the laser beam is white hot. I think giving it 2 colors makes it look much better. Since we used relative values, the white beam will be centered over the gold beam regardless of laser width. 10 pixels is still too wide. I want the width of the beam to match the muzzle of our laser gun. 5 pixels seems good. Each laser subclass will also have a damage value. This will define how much damage to the enemies it will do per tick. Let's actually implement that damage and hit enemies with laser. Right now, it still doesn't interact with them at all. I can put the following logic in multiple different places in my codebase. I decided to put it inside the render method on laser class because I like to keep the code organized and easy to navigate in. It makes sense because I only want to check collision between laser and enemies when we are actually drawing the laser. If you remember, we have an array that holds all currently active enemy waves. In our game, there's always only one active wave in that array, but you can make the game more difficult and release the new wave before the previous one is fully defeated. For example, each wave object inside the waves array has enemies array inside of it, as we defined here on line 280, and that array holds all currently active enemies in that wave. To cycle through all active enemies, I will cycle through waves array, and for every object in waves array, there will be only one in our case. We access its enemies array and also call for each on that. For each enemy object in that array, we call our reusable check collision method we wrote before. We pass it enemy and this laser object. If enemy and laser collide, I will call hit method on enemy and I pass it this.damage of the laser. We defined it here on line 32. Before I test it, I will also cycle over all bosses inside boss array. Again, there is usually only one active boss, but if you want, you can push multiple bosses at the same time. Or you can push the next boss when the previous one has only a few hit points left. I will leave the game design details on you. I'm giving you all the tools. Design your own game. For each boss in boss array, we also call check collision method between that boss and this laser object. If they collide, we call hit method on the boss and we pass it damage of the laser as an argument. So we have our render method, which will run over and over as long as we are pressing the number 2 key on our keyboard. When I test it, you will notice the laser is very powerful. It's kind of fun to be able to destroy all enemies easily, but it takes all the challenge away from the game. We want to give the player fun, powerful weapons, but we don't want to make them overpowered like this. The reason it's so strong is that it hits enemies for 0.3 lives per animation frame, and we are running this at 60 frames per second, or even faster. I want the laser damage to tick slower, and I want to make sure the damage is same or similar for people on old computers and people on new gaming computers with high refresh rate screens. We already have a variable called sprite update that we set to true only for one animation frame every 150 milliseconds. We are using it to slow down how fast we cycle through animation frames in the sprite sheets. And here we can use the same variable to slow down how fast the laser ticks when it burns through enemies. Only when this.game.sprite update is true, only once every 150 milliseconds or so, we want to check collision and actually hit enemies and the boss with our long-range lasers. Now we can see that the laser has a bit less power. I think this is so much better. We can always tweak this by adjusting this.damage value on small laser subclass. Until now, our basic attack was hitting for 1 life per hit, but now we have lasers that can deal damage that is not exactly 1. We can end up in a scenario like this. When the boss has less than 1 life, it should already explode. Having 0.8 lives doesn't count in this game. I want the boss to explode as soon as its lives get below 1. I go down to the boss class and I need to look at this code block. It says if lives are more than 0, which means that boss that has 0.1 health is still considered alive. I will change it here, 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 and here. In all these places, I replaced that check everywhere with this.lives are more or equal to 1. Make sure you change it in all these places here, 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 and also here. Sorry about this. Now let's try to use small laser on the boss. I will slowly burn through its tellurium shell and notice that as soon as we get below 1 life, the boss explodes. Perfect. We can adjust the damage of the laser here. Good, it still works well. I put it back to 0.3. I think that's the right value for the small laser. The big laser will be much more powerful. Of course, we don't want the boss lives to display so many decimal points. I go down here to draw method on boss class. Here we draw boss lives, so I wrap it in math.floor to round it down and remove the small numbers that come after the decimal point. Let's test it again. The boss should start exploding immediately as soon as its health drops below 1, and we should never see 0 lives. Yes, we are making a lot of progress. Okay, super laser. I come here and I copy all the code inside. I paste it inside big laser subclass. Width will be 15 pixels. Damage will be 0.7 per tick, so more than twice the damage of the small laser. On the player class, we create an instance of big laser like this. Then we can add one more else if block here, and if key that was pressed is 3, player frame is 3, which will give us the final frame, where the arms open and make the room for the massive laser beam, and also to make sure that the tips don't melt from the heat. Big muzzle with laser lens inside pops out to fire our ultimate weapon, a super laser. We draw and update the laser by calling its render method. Small laser and big laser. You can see it deals more than double damage. It's actually too small. I want the laser beam to fully fill the cannon. Maybe 25? Watch how the player animates to match the weapons. Basic attack, small laser, and big laser. What do you think? We can destroy enemies easily now. The new laser weapons are especially effective against groups of enemies, since they damage the entire column of enemies all at once. I want to put the player and the laser beam behind enemies, but in front of game text. I cut it and I paste it here. After we draw projectiles, but before we draw the boss. What gets drawn first is behind, in cases like this when we draw everything on a single canvas element. Try to play the game for a bit and let me know what you think. Do you have any other weapon ideas, something completely different than this? Like, what if we send out a swarm of small robots? Or how about an electricity weapon? The game has become kinda trivial and easy now that we used lasers without limits, and actually there is no reason to use the small laser if we can use super laser non-stop. It would be much better if the player had a pool of energy they need to manage. Before we do that, I want to make sure the boss is only hit when it's fully visible. I don't want it to have reduced lives already by the point it floats on screen, so we will check collision between the boss and lasers only when the vertical position of the boss is more or equal to 0, once the boss has fully entered the game area. I test it. Yes, that works. Let's add resource management mechanic. The player will have an energy bar. Starting energy will be, for example, 50. Max energy will be 100. If we don't pay attention to our energy levels, we can also overheat our laser, which disables it for a short while. I will call this property, for example, cooldown. We will display the energy bar down here inside draw status text method. Again, we will use a for loop that will run once for each point in energy. For each energy point, we will draw a rectangle. We will space them out 2 pixels apart, and vertically, I guess 50 pixels from the top. Each energy rectangle will be only 2 pixels wide and 15 pixels tall. Since we are drawing them one next to another, they create a bar. This value is the spacing between the bars, and this is the width of each bar. If they are the same value, we see one continuous shape. If the width is less than spacing, we see individual rectangles. You can play with these values, and it will make sense when you see how it reacts to different values you give it. If I do 15 plus here, that will be margin from the left edge. Vertically, I want it probably 130 pixels from the top. Left margin 20, spacing is 2 pixels, and the width of each energy rectangle is also 2 pixels, so we are getting one continuous bar now. When we shoot the lasers, it will be costing us energy. Up here I say this.game.player.energy minus equals this.damage, which means that now small laser is cheaper than big laser. So sometimes small laser is the better option. Now when I use lasers, you can see it actually depletes energy. The rate at which it depletes the energy is equal to laser damage, so small laser costs 0.3 energy per tick, big laser costs 0.7 energy. I want the energy to slowly recharge. If the current energy is less than max energy, increase energy by 0.05 per animation frame. I test it. Energy is recharging. If I deplete it, it will start recharging automatically again. Good. We need to prevent the energy to go into minus values. Player has to manage energy and watch the energy bar. If they leave it for so long that the energy gets below 1, it will trigger the cooldown. We overheated the cannon and now we have to wait. It's a small punishment for not paying attention. If we want to play optimally, we never deplete the energy below 1, so we never trigger the cooldown. I can do else if here because energy can never be below 1 and more than max energy times 0.2 in the same animation frame. This will save us a little bit of performance. If energy drops below 1, cooldown is triggered. If the energy refills back to 20% of maximum energy, cooldown is set to false. Laser cannon had enough time to cool off, and we can use our lasers again. I want to make it visually clear to the player when we entered a cooldown, when we overheated our cannons. So down here, where we draw that energy bar, we will change its color. I will wrap this in save and restore to make sure these fill colors don't affect any other shapes we draw on canvas. We are quite far into this class, so instead of a standard if-else statement, I will use ternary operator syntax here as a simple single line if-else. If player cooldown is true, set fill style to red. Else, set fill style to gold. Easy, let's test it. Energy bar is gold by default. That means everything is alright and we can use our lasers. When I use my lasers without paying attention to the energy bar and I let it slip below 1, we trigger the cooldown. Energy bar turns red, which means our lasers are overheated and we can only use the basic attack for a while. When we reach more than 20% of max energy, now the bar changes back to gold color and we know we can use the lasers again. I have a feeling we are still dropping below 0 energy. I can make this really clean by doing this. Here is the parent laser class and its render method. We never call this render method directly. We are always calling it from one of the subclasses here. So let's make sure we only render the lasers when player energy is more than 1. At the same time, if cooldown is false. Only then we draw and update small laser. And I copy this. And I do the same thing for the big laser. Now, for the reason why I'm putting render on subclasses. So far, these methods are identical and we know when things are shared, they can sit on the parent class. Subclasses contain only properties and methods specific to that subclass. If I deplete my energy and I try to shoot the lasers, the player ship is still animating as if we are shooting the laser, but since we are on low energy and in cooldown, the laser beam is not coming out. It might be fine for your game, I'm not sure what you prefer, but in my game I only want the player sprite sheet to animate like this when we are actually shooting the lasers. So, instead of swapping player frame here and here, I delete these lines. We will actually swap player sprite sheet from here, which means that the player will only animate these weapon attacks when we are actually rendering those weapons, those laser beams. Small laser is frame x2, big laser is frame x3, same as it was before. Now, when I'm in cooldown, no laser comes out and player sprite sheet doesn't animate that weapon attack.